Afternoon, everyone. It's the afternoon here in Edinburgh anyway. What I was going to do is I was just going to short talk here, which is really going to introduce the MSc as a program of study and try and explain what it is that EPCC does, what we teach in the MSc, and what high performance compute is about and what it's used for. Of course, you'll learn a lot more about this should you come on the MSc, but just a brief taster. And hopefully you'll all be aware of the MSc website, and I've got the URL there. So a very brief overview. I'm going to talk about what EPCC is, which is the organization that runs the MSc. I'll also talk about what high performance computing is, why it's useful and particularly interesting at the present time. And at the end, I'll just give a brief overview of the kind of things you'll learn on the MSc, but Judy will be talking a lot more about the MSc itself later on. So EPCC, originally we started out as the Edinburgh Parallel Computing Centre, which is a reasonably explanatory name. I will explain what parallel computing is later on, but nowadays we're just called EPCC. We're an institute in the School of Physics and Astronomy, which is part of the University of Edinburgh. So the MSc is awarded, should you get the MSc, it's awarded by the University of Edinburgh, and EPCC is one of the institutes in the university. EPCC is slightly different from a normal university department in that we're really focused purely on supercomputing, and without doubt we're the UK's leading supercomputer centre, and the picture there on the screen is a picture of the current Hector system, which is the UK's national supercomputer, which is used by all researchers in the UK, and we run that system. It's based here in Edinburgh, and it's actually a system which, if you're on the MSc, you get a chance to use. In fact, the MSc students were using that machine today, this morning, using it for some of the practical sessions and logging on. So what is high performance computing? Well, many problems in science and industry require a lot of computer power to solve. You have some problem. I've got a couple of pictures there. The first one is, if you're worried about the Earth's climate, that's actually a picture of the temperature of the Earth's oceans. Or on the right-hand side, if you want to design new sources of power, that's a picture of the new fusion reactor ITER, which is currently in construction in France. If you want to tackle these problems, the only feasible way to do them is to use a computer model. They're far too complicated to solve theoretically using a pencil and paper. And so you need enormous amounts of computer power to solve these problems. And modern computers require modern supercomputers require special techniques to program them. And generically, we call these high-performance computing techniques. But in fact, possibly an important distinction is that all modern computers are parallel machines. All modern supercomputers are parallel supercomputers. And we'll explain what that is in the next slide. So as it says in the title there, parallel computers have many processors, many CPUs. And until maybe 5 or 6 years ago, parallel computers were very specialist systems. But why high-performance computing and parallel computing is particularly interesting right now is that parallel computing is appearing in all streams of life. So the picture there is a picture of just an everyday laptop, very much like the laptop I'm using at the moment. And even machine is a small parallel computer. Probably your machine has multiple cores, maybe 2 processing units. Next to it is a sort of a standard desktop server machine, and it might have 4 cores, 4 processors. I've got a picture of the PlayStation 3 next door, and that actually has 9 processors, a master processor and 8 slave processors. So even standard equipment you can buy for gaming in the high street now uses parallel computing. And moving up the scale, a computing cluster, which a department or company might have about 100 processors. The Hector supercomputer, which I showed you a picture of in the earlier slide, actually has 40,000 processors. So clearly, you need to learn special techniques and programming skills and approaches to programming these machines, to taking a problem you want to solve and running it efficiently on 40,000 processors. And those are the techniques that we teach in MSc. In terms of the MSc input, we take our students from quite a wide range of subject areas. Although EPCC, as I said, is an institute in the School of Physics and Astronomy. We don't assume any physics knowledge at all. In fact, our students typically come from two backgrounds. They come from the more applied area of computer science, where people are interested in programming, or from the physical sciences, physics or chemistry, math. People are interested in simulation. That's about solving problems using computers. So we take those two areas, so the simulation side of physical sciences and the applied programming side of computer science, and put them together to teach all the knowledge that you need to program high-performance computers. And that area is now becoming known as computational science. Computer science is the scientific study of computers. Slightly confusing, but computational science is using computers to do scientific investigations. We take these two areas of physical sciences and computer science and put them together, and that's what we teach in the MSc High Performance Computing. So as I said, this brief summary, the MSc and HPC teaches you all the sort of fundamentals and techniques which you will need to program the whole range of parallel computers. And I said particularly interesting at the moment is that range of machines isn't any longer confined to just a few very large national supercomputers, but almost every computer you'll come across from now well into the future is going to be a parallel machine. And so these techniques, high-performance computing techniques, are relevant across the whole spectrum of computing. And the two which we aim at, the two sort of driving forces behind the MSc are, one, getting the performance. We're always interested about getting the best performance, making your programs run as fast and efficiently as possible. But also we quite a focus on high quality and robust software. That comes from EPCC's other activities, which are in the industrial sector, working with commercial clients. We have a lot of history of quality of software development. So putting together good quality software to get the best performance is what the focuses of the MSc are. And there's a picture there of some of the graduations, the students who graduated a few years ago.